Welcome, boys and girls, to my lesson on vectors form 2. Okay? The vectors that you have been seeing, they were to suit people who have done vectors, then it would help them revise questions with ease. If you did not understand vectors, I'm doing it from scratch. That is form 2 level. This is lesson 1. So you have to go through all of them, then you can now be comfortable even with the ones I had shown. So this is form 2, scratch. Vectors, form 2, lesson 1. So what do we understand by the word vector? Okay, what do we understand by the word vector? Now, in physics, form 1, and everyone went through form 1. So just to remind others, we have two quantities. On Earth, two major quantities that we have are vector quantities and scalar quantities. What does that mean? Vector quantities are quantities which have size and direction. Some people use magnitude for the word size. Size is quantified using a number. Okay? You must give us a number to show us the size. If I ask you, what is the size of your waist? Okay? Boys and girls, you are not going to tell me it is medium. Wrong. No. Don't say it's medium. Tell me it is 28 inches. It is 20 inches. 20 inches. Something like that. 20 is a figure. It is figure that give us the size. Okay? If I tell me the size of your shoe, you are not going to tell me small. No, that's not the size. Why? There's no number. You tell me 45 USA. It's like a half meter rule. Your shoe size is a half meter rule. Something like that, eh? Half meter rule. You see, half meter rule. That is quantified using a number. If I tell you what is the size of your wristwatch, don't say me it is very big. No, very big has no number, right? So you understand size, magnitude. Then direction can be given in numerous ways. Okay, numerous ways. We can have bearing, we can have an arrow, we have the angles, we have compass, north, south, east, all those describe direction. But if you go back at form 1, you are given a quantity by contrast, scalar. A scalar quantity is the one which has only size. We don't need direction. It doesn't make sense even if you put direction. Eh? Hey boy, go to the market and get me some meat. You will ask me, how much? Then I'll tell you, 2 kgs for roasting. 2 kgs. I will not tell you, go and bring me medium meat. No, there's nothing like that. You tell me 2 kgs, but you cannot tell me 2 kgs in the direction of north. It does not make sense. Okay, so that is scalar, which has only size. Vector quantities have both size and direction. So what is the example? Now, whether you forgot physics or not, force and displacement among others. So I would say the force, displacement, I put ETC to show is not limited to that. Okay? Now, look, if I tell you push, definitely you are going to lean towards the direction of push. Okay? So you are trying to push. There is no way you can lean backward and push unless you are abnormal. It can't work. You only lean. So already when I tell you push, the direction has already been handled. Okay? And then I say 1, 2, go. Whatever you try to put in this action for a body to move from one point to another is what we call size. So the force you are using there has some quantity, is measurable. So we say, you have put 20 newtons. See, figures 20, quarter. It is figure signified by a figure. Okay? So already you are in the direction of pushing because I told you push. You cannot be abnormal. I say push and you are leaning backward. It can't work. It can't work. So look, push is already taken the direction of push. So the direction is away from you. Then how much? When I counted, I measured 20 newtons into this action. So the size of force is 20 newtons. Then the direction, the mind even interprets direction straight by positioning the body. Okay? So that is force. Size, direction. Can look at this young man, direction. Now, I've given you also displacement. In the course of this push, we will be transferring this table from position A to some position B, from position A to some position B. Okay? So you see, from A to B, that already tells you direction, AB. And that direction is different from BA. It is different, right? So already the direction is there. So from A to B, what again are we going to measure? The distance between A and B. We shall use measuring tape or meter rule to know how far is B from A. How far did the body go? You can say distance. By the way, distance is the length of path taken. Distance, length of path taken. Displacement, length of path taken in a given direction. In a given direction. Get it? So we are going to get how far is B from A. We shall say 12 meters. So you see, the figure 12 signifies size of that movement. Since it is from A to B, direction is already given. It is towards that side. It is towards that side, okay? You know, that side. That looks like karate. That side, right? So you have that. Now, if I put 10 Newton, then 10 Newton become the size, comes the magnitude. The direction is shown using an arrow. Sometimes we use arrow. So you see, I can use 2 capital letters. Okay? 2 capital letters from A to B. So when I write for you AB, it's interpretation. You were here, you went there. From A to B, direction is specified using capital letters. And then we can now measure the length to give us magnitude, size. And size has figures. Okay? Now look at this example. I want us to focus here. If I can focus here, it will be very good for me. Yes, focus is on. Look, so this is a line segment. This is a line segment. The only thing it has so far, the thing it has so far is size, because the length can be measured from here to here or from here to here. It doesn't matter. Length can be measured, but it has no direction so far. The way it is, there are 2 possible directions. So you have to beef up your understanding. The way this line segment is, if I ask student, can you give me the name? He will say AB, which is correct. Another boy will say BA, which is correct. Okay? So if I draw the line segment and I don't give you the capital letters, don't jump into conclusion. Just like in trigonometry, if I have not given you the angle in a right angled triangle, you don't jump into conclusion. Adjacent and opposite. Opposite of what? Right? I have to give you the angle in a triangle for you to tell me the opposite and adjacent. But you can tell me hypotenuse, the longest side. Okay? So here, what are we talking about? This is just a line segment. This is just a line segment here. So if I say my line segment is AB, then what have I taught? The direction is from A to B, if you are getting me right. From A to B. So I'm right here. AB can be represented like that. Now, if this is 3 centimeter from A to B, then this becomes my size. AB, if I told you draw AB 3 centimeter, draw AB 3 centimeter. So that now is a vector quantity, because AB has been described using 2 capital letters, and you start from A, you measure 3 centimeters to B. Get it right, okay? So if I don't give you any letters and I've drawn this line segment, this, the way it is, you cannot say it is a vector. It is lacking the second component of direction. But if I tell you now, draw AB such that it is equal to 3 centimeters, then this is a vector where AB simply means that. AB tells you where you are, and the second letter is where you are going. I hope it is clear. Small letter on a line can also represent a vector. So vector can be represented by 2 letters, 2 capital letters. The other way is a small letter A. But look at that. Now I don't have capital letters. I have a direction. Okay? I don't have a capital letter. I have a direction. But in conclusion, I can also tell you, let A B equal to A. That is a symbol sometimes we use. That is, the use of capital letters makes use of also small letter. That this strictly tells you from A to B, let it be this. Okay? So, what do I mean here as I finish? Look at this. This is A, B. I've told you this is A. Now, what would be BA? Right, still, I draw the same thing and I write B, A. And I do this. Remember? Now this is written as B, A. Using capital letters. It is from B to A. This is the first letter. From B to A. This is what it is saying. Now, if you look at this, we say you have done the opposite. You have done the opposite. So this is equal to that to you have come back. Going back. Going to B is A. Back to A, opposite. Back or opposite. Positive and negative have meaning. Okay? Positive and negative have meaning. So, if A to B is this, just like from Kikuyu to Nairobi. Okay? From Kikuyu to Nairobi, there is a board in front of the vehicle reading Kikuyu, Nairobi, meaning that we are going to Nairobi. When we are coming back from Nairobi to Kikuyu, it will be written Nairobi, Kikuyu. Okay? So they have just reversed the order. So this negative is opposite. You are doing opposite. Okay? If I tell you AK is equal to C minus B, then what will be KA? What will be KA now? If AK is C minus B, and remember, the minus there is to reverse. So I'll reverse this from K to A, it will be negative C plus B. But that, we can continue with it next, just to jog your mind. So this is the basic of vectors. Okay? So what do I conclude? Vector is described by two things, size and direction. Size and direction. Size is a figure. Direction, we use two capital letters or an arrow. Okay? If you can master that, next time we do something to build on what we have. Two things you must always remember: size and direction. Capital letters. Two capital letters. The first one is where you are, the second one is where you are going. That gives you automatic the direction. Okay? So, folks, can you read this again? Go through it. I'm starting from scratch so that you are not left. This is Form 2. Every time you will see, this is Form 2 Lesson 1. It will be, next is Form 2 Lesson 2. Keep on subscribing, you get that flow. Bye-bye.